right, good afternoon, everyone. My name is Jesse Dunn. I'm a member of the Strategic Technical Account team. Kind of handle a lot of the hands-on with our clients. Joining me on stage is Garrett Klingbeil, a member of the Support Engineering team. Doug Worley and Josh Roskis are both part of our professional services team. Today we're going to be talking specifically about Tomcat and MySQL and some of the various settings that we tune in support, settings we modify, things that we change to help smooth out the Tomcat and SQL connection. We're also going to be touching a bit on the monitoring briefly. But I'm definitely open for a Q&A session afterwards. Expecting quite a bit of them, so please feel free to bring your questions. So, I believe we are going to go ahead and get started with Mr. Roskis, and you're going to cover the basics for us.
All right. Let's find our spot here in the slide deck, because we're behind a little bit. All right, let's talk to you about the basics. So first things first, I guess, when you guys call into support, we just want to make sure we have the terminology right and make sure we're all on the same page. So look off to the left side here. We have our clients. This can be your macOS, iOS, tvOS devices. And then whenever they talk to Jamf Pro, whether it be a self-service, a check-in, policy recon, whatever, they open up a connection via thread to the Jamf Pro instance. From there, Jamf Pro to MySQL opens a connection. So really the two things we just want to take away from this slide is thread is between client, Jamf Pro, and then between Jamf Pro and MySQL, it's a connection. Okay, so threads get created for things like self-service. Whenever you launch it, don't even have to run an application, just launching it creates a thread. Whenever a device checks in to install an application or run a recon, as well as anytime you as admins visit the web interface, that also opens up a thread. All these threads then live inside Tomcat in what's called the maxThreads pool. This maxThreads pool is defaulted at 200. It can be increased based on the number of devices you have and the amount of traffic on your network. One thing to remember though, when you increase this, Tomcat does eat up more and more resources. So keep that in mind. It's not something you just want to go ahead and increase right off the bat. All right, so the other side of it, connection. So let's say that Tomcat receives a request from a macOS device to install a new application. Once Tomcat receives that request, it's going to reach out to the database, MySQL, in the form of a MySQL query. Once that query is processed by MySQL, it is then going to give a response back to Tomcat. Okay, so what kind of resources do we allocate to this? So first and foremost, if you can provide a dedicated virtual machine for Tomcat and MySQL, that's amazing, that's perfect. They don't have to fight for resources, reduces the chances of any kind of conflicts there. As far as resources, on a high performance environment, we're looking probably between 8 and 16 gigabytes of memory dedicated to Tomcat or MySQL. We also have environments that only have 1 and 2 gigabytes. So there really is no magic equation. So it's not a simple thing you can do. Always just plan for the worst and plan to overscale if you can. Resources are pretty cheap nowadays, and it's just going to make your environment that much more snappy. As far as adjusting these settings, which we're going to get in more detail here, we do have a Jamf Nation article on that, and there's the short link for it as well. It's called Allocating Additional Memory to Tomcat. And just to kind of round it out, what it's going to say is for macOS, you have to edit the plist file on there. For Windows, we're going to use an executable that's there for us. Then Linux, we're going to edit a script. And all those you can use to adjust your settings in Tomcat. So you can scale vertically by increasing memory and processing power. What about horizontally? So as a guideline, when is it time to kind of scale out horizontally? Usually when you're looking at 8 gigs or more dedicated Tomcat, it's probably to start thinking about adding another server into that group. Clustering, if you don't know, is just the ability to add an additional Jamf Pro server into that group to handle more threads from your clients. In order to do this, you do need to utilize load balancing. Many different appliances out there for that, but that's going to allow you to balance those thread connections for your clients. All right, hand over here to Garrett.
So how do we know when these things need to be adjusted, these settings? Basically, we need to monitor what's going on in the environment, and the most basic way to do that is just reviewing logs. And if you've ever had an issue and put the JSS into debug mode, sometimes you can see that a 100 megabyte log file can get generated in about a minute. So that's a lot of stuff to go through. And if you're trying to get like a historical view of what's going on, it's not the easiest to do with only logs. So there's some software out there that we can leverage and connect into the JSS and the Java virtual machine to kind of make graph historically and monitor what's going on. So some of these appliances are JConsole, which comes with every JDK install. There's Zabbix, which is an open source one. I mentioned these two because the next slides are going to show some screenshots. But there's lots of third-party applications, both free and paid. Okay. So in order to monitor what Java's doing, we need to enable the JMX. And this is done in those same files that we talked about with memory allocation. setenv, Tomcat 8w, or Tomcat plist. And they're just some Java arguments that you have to put in place to enable the connection of the monitoring software to the Jamf Pro server. And there's really good documentation on Oracle for that. You just search for enabling JMX. And it can be set up with authentication requirements and all different security settings. So once that's set up, then you log in if you're using username and password to connect the monitoring to the Java virtual machine. Once we get connected, we can get some information here. This is a screenshot of JConsole, and it's showing heap memory, threads, CPU usage, and classes loaded. And this screenshot in particular captures a JSS restart, so it's not. It's a pretty big perturbation. But when we're monitoring, this can monitor for days, weeks, months, and it's good to do both in times of good times and bad times. Good times you can get your baseline, and in bad times use it to troubleshoot and see what we need to change. And also, if you're just implementing new workflows, you can get a direct, cause and effect of what you're doing for these different parameters. This is a screenshot of Zabbix. With different appliances, you can get some more information outside of the standard, and this is just showing network traffic for the server. So you can see maybe at 8 o'clock every morning, all your devices are running a specific policy, and you can see kind of what effect that has in that parameter.
Thank you.
Next, we'll talk about Tomcat configuration, diving into the same files we looked at a moment ago for memory allocation or turning on monitoring. We can play with a few other files as well. So diving back to the terminology, looking at how Tomcat accepts incoming connections from your clients, those are handled in the threads. An analogy for this could be like you're at the deli and you want to get your sandwich, but then you go up to the machine, the little red plastic deal, and you pull the number off, and you've got your position in the queue. the more threads that you assign in Tomcat, that means that you have more people waiting to get their sandwiches. We've cleaned up the Server.xml file here. That is where the threads are defined. And we've got one global position here where you can define how many threads are available to the entire Tomcat server. The default is 200, and usually that's fine to start off with. That thread pool, max thread pool, is then referenced twice more in each of the two connectors that Tomcat stands up. This means that you can configure the one value for that entire Tomcat server, and if you're then connecting it via 8080 for clear text traffic, HTTP, or via 8443 for SSL traffic, you don't need to worry about each socket individually. The whole server will negotiate up to that total amount of max threads that you've defined there. Obviously, there's much more in this configuration file. There's many other values that are required to be there, but we've just sanitized down to the salient points for this discussion. So, if we were to look at some of that trending monitoring data that Garrett was just talking about, that could tell us that potentially we need to increase the threads. If we were to do that, that would put more constraints on Tomcat, so we might need to consider bumping up the memory that Tomcat has available to make room for those greater threads. If you've got a number of loads coming in via load balancer, being spread across multiple web applications, best practices would be to have the entire cluster configured the same. So be fastidious in your monitoring, you're saving the files. If you're using something like an Ansible workflow that can automate those configuration changes, that's fantastic. Otherwise, just make sure that when you stop Tomcat and you're copying the files in or making the edits that you're consistent across the board. One thing about that is Tomcat and MySQL both handle connections in a particular way. By having connections come in and out in line versus having more simultaneous threads, you can find a better response time. So by having more threads, getting more communications in line, things can be processed in and out, passed off, move on to the next connection. So if you're to look at the memory utilization, you're starting to see CPU, RAM spiking. The graphs are looking really jagged, lots of up and downs. That could mean that potentially we need to go back and reallocate resources differently to the way the whole Tomcat process is handling things. Another thing that can cause Tomcat to potentially spike are some, like we see here, long SQL queries. So if you've got a really gnarly smart group that has a bunch of nested connections and maybe like nested groups looking at other values in the database, that can sometimes take time to process, and you could see that running through. So if you were to have a view of your MySQL queries, you might be able to track that back to the Tomcat configuration and see where that query is just hanging out for a long time. So the client, through the thread, through the web application, it's hanging out on that query, hasn't gotten the response back yet, just taking up space in the Tomcat thread pool. Other things as well, obviously your server hardware will have an effect, bringing it back to why virtual machines are so great, because you can then very easily at a glance determine where we need to allocate new resources, drop them real quick, add more RAM, CPU, what have you, reboot the machines, and you're good to go. Again, the defaults start at 200. Maybe that's not quite great. Maybe we're looking at the logs, looking at the trending, the monitoring information, and we determine, all right, let's bump it up. But how do we decide where to bump it up to? Move up maybe 250, 300, move up slowly. Start to see, does anything else change? Do we start to see the graphs level off? Do we start to see more consistency? Doing this over time is useful because maybe in the morning when everyone comes on you'll have a big spike. See if you can level off that spike every so often. This is hard to do quickly. This oftentimes might take days, weeks, months to really tune things properly. This point comes back to the slide earlier we're talking about planning for the worst. If you're working at a school and 8 a.m. Monday morning, first day of class, everyone turns on the machines and the flood of connections come in. That's kind of the worst case scenario potentially. You don't want to have the machines overload your Tomcat servers. So once Tomcat is processing things, those threads from the connections are handled within Tomcat. The configurations are sorted out, and then it then needs to determine where to get its information for the response back to the client. At times, those will be converted into a MySQL connection for them to query the database. And there's an assumption here which we haven't gotten into in this topic. We're keeping things down to MySQL and Tomcat. In a clustered environment, you might yet soon will be required to have the Memcache server. And there's probably some curiosity about Memcache on this discussion. We'll have more questions about that at the scalability panel tomorrow. And we could field some questions here about that, but we wanted to keep, just for time and brevity, this discussion to just Tomcat and MySQL. Some of those queries that might be determined by the database or for new or the things that the process haven't sorted out yet. The number of connections to the database might be lower than the incoming threads because my Memcache might have already sorted out what that query would be. So for example, you've got a load balancer, you've got multiple Tomcats. One Tomcat might have already sorted out that group membership, that extension attribute. It's then saved into the Memcache server. The next one comes along, reads Memcache, fine, goes along, back out to the client's good to go. If Memcache does not know about that discussion, then it needs to query the database to then do a longer query on that setting. So over time, the threads are converted, if it needs to figure it out, to a MySQL connection, and then that is then sent off to the MySQL server. Those connections are handled in a different file. There's the Database.xml configuration file, where the settings we see are right here. There's the min pool size and the max pool size. By default, 5 minimum connections. So if you've got one Tomcat server connected to your database, you run a full process list, you'll see 5 connections minimum if everything is working accordingly. By setting up the max pool size, that means that each Tomcat can go up to that maximum amount. Now, show of hands, who has taken the CJA, soon to be called 350 course? Good group of hands. You probably all remember that one section as we talk about scaling this out. So if you've got, say, 5 Tomcat servers, you need to take the maximum number of connections based upon max pool size across all of those members. So 5 times 45, math in my head, I can't do it correctly, plus 1 for extra connections. That's the total amount that MySQL will need to know about. What we found when online services was doing some of this trending and monitoring and looking at the hosted solutions that we're providing, that by having the max pool size be a larger amount, that meant that MySQL had to consider potentially having a much, much larger number of connections it could accept in. And if anyone's tried to juggle like 5 balls in the air, you're in a project trying to multitask on 20 different things, you're not going to be as agile sorting out any one thing. So if you can limit down what you're responsible for, you're then going to be more quickly able to sort out those connections. Long story short, we found that by reducing the number of the max pool size, but by increasing the threads, Tomcat was more performant. The MySQL database was more agile because it had fewer connections to worry about. Therefore, it could process those connections coming in and out of the database more quickly. So due to that, there's now a default change for a new deployment. if you're to install a new on-prem Jamf Pro solution, the default max pool size is now 45. Previously, it was 90. Part of this is due to the fact that MySQL handles operations coming in and out in a serial fashion more quickly than things in parallel. One thing at a time. Then again, bringing it back to the Tomcat.mysql, by increasing the threads and also dropping the max pool size, it's kind of like what your mother told you growing up. I mean, chew your food one thing at a time. Don't eat too quickly. By taking smaller bites and more of them, MySQL was able to process everything more quickly and then move along. So related to the monitoring things like, not the same exact thing as JMX or JConsole or Zabbix, there's some things we can do to monitor the Tomcat MySQL connections. If you open up the MySQL console, run a show full process list, that's to show you at that one point. There's also a script available from Jamf support called the processlist monitor. That's the bash script that just runs a MySQL admin command to dump out the full process list every second to a file. So by looking at that information over time, that can help you give us some information about how many queries there are. You can expand out the process list to a full process list to show the entirety of the query being performed. And that information could help us determine, well, maybe we've got some bad configurations. Maybe the workflows are what's causing Tomcat to take a hit. So maybe we need to go back and look at our smart group logic or our policy logic to determine why MySQL is hanging on so many long queries. So, changing the pool size. Normally, keeping things at the defaults is best to start off with, but occasionally, obviously, we're here to determine those times when it's not. And we use the term tuning in this title of this discussion here very intentionally. There are no absolutes in this. Everything is dependent upon your network, your workflows, your objectives, why you're using Jamf, and even the network and hardware that your machines are running on. By running the process list and looking at the number of queries, taking the time that it takes to execute into consideration, that can help us determine how we might look back to Tomcat, look back to the server configuration for both MySQL and Tomcat, and maybe come up with other tuning settings based upon what we see in the process list logs. And of course, in a scaled environment, having more Tomcats is not always better. Bring it back to the total number of connections in MySQL, the number of web apps definitely will have an effect on the total performance of the server. And with that, talking about MySQL connections, I'm going to pass it off to Jesse.
No. All right. So, as some of you may have guessed, when it comes down to it, SQL is the core of everything. SQL is the heart of the server infrastructure. If we have an issue with SQL, that's going to bleed over to Tomcat. It's going to affect performance. Whereas if SQL's happy, maybe there is a Tomcat-specific issue we can examine. But at the end of the day, SQL is the core of everything. If we're seeing an issue with SQL, that's where we're going to start. We're going to be discussing the way that the web app takes a connection, how SQL handles it, and then sends it back to the web app. To start with, for all of the SQL modifications, those are going to take place in the my configuration file. It's a my.cnf for Linux and macOS environments, and a my.ini for a Windows environment. Right here, we do have an example of a very basic my.cnf on a Linux installation. With Windows, you will see a much larger segment of data to work with. Windows has a larger number of defaults that get set automatically when SQL is installed. Both Linux and Mac OS have pretty bare bones installation. It allows you to modify and add quite a few settings as necessary, kind of ad hoc. You can modify it via command line. You can also use a text editor. The JSS database utility will let you modify a couple of settings by default. Once you start getting into the nitty-gritty of it, might as well just open it up in a text editor of some sort. It's going to give you just a whole lot more options for what you can modify. Settings changed inside of the my configuration file will only be applied when the SQL service restarts. So that means if you do make any modifications, you of course have to restart the service. There are some settings you can change dynamically on the fly through the SQL command line interface, but they will be lost the next time you restart SQL. For the most part, these settings are all going to be inserted under the mysql.d portion of the my configuration file. If that's not currently defined, you can go ahead and add that in yourself. Most of the values we're going to be discussing today, kind of the defaults that we just kind of start with, are all mysql.d variables. And with Windows installation, a large number of these are already pre-configured. Stress points for MySQL. As Doug already mentioned, we kind of monitor the process list output. I got a couple of screenshots coming up in case anybody hasn't seen that. We look for the process list, CPU, and RAM for the MySQL service. Do we see any one of these spiking abnormally, CPU, RAM, or do we see the time on our queries running long in the process list? With SQL especially, there is no set default values that we can modify. It's a large number of values that are working together, so it really is more of an art form than a formula. And if we do see spikes inside of Tomcat, it can stem from SQL, and that does bleed over to Tomcat. If SQL's having an issue, Tomcat will likely be experiencing an issue as well. So, two quick little screen grabs here. The top entry is kind of just a bare bones, kind of what we focus on when we look at the process list. You'll see the ID of the process, the database, the host, user, and then the host. And then the type of query that's running. Here we have in our example just a straight query running against the database. The time is the second to right column, and the current status of the query is what we'll see in the rightmost column. The bottom one's a little bit more information to it, the actual query that's running. I wasn't sure how it was actually going to show up on the screen, so I wanted to make sure you all had an example of both. So, starting points for the my.cnf. The variables we have listed here, I'll touch on a little bit more in depth. These are kind of the settings that we start with, things we look at just to get started at a base, and then as necessary, we can examine the SQL installation and look into it a little bit further. With the max connections, I noticed a large number of people raise their hands about Doug's CJA questions. So as you're aware, that's the maximum number of connections the SQL server will accept. We do need to make sure that this matches the total number of web apps and their max pool size, plus one for additional connections such as the JSS database utility or a manual connection onto the server. This max connection is just a ceiling. It doesn't really affect performance to any degree. It's just the most amount of connections you can have simultaneously. So if you do have a number of processes coming in, you can scale this a little high. Doesn't really affect you too negatively. The optimizer search depth. This is an oldie but a goodie. We've been modifying this one for a while. The optimizer search depth handles the statistics portion of the SQL query. Some of you might have noticed that in the screen grabs that I have. It's basically the way that SQL calculates the best optimized way to run the SQL query against all of the various databases. With a default installation, it does default to 64, and that means SQL is going to try and figure out 64 different ways to run this query before settling on one and just going forward with it. Based on the queries that we're running, we've found that the optimum number of optimizer search depth tends to hover around the 3 number. It's enough where SQL can have, a couple different tries, look at a couple different ways to run it, but also just at the end of the day, execute it. Query cache type, this is kind of a new one. Some of you might have heard this in the recent couple of months. Query cache type is kind of a built-in way for SQL to cache commonly run queries. In small environments where the same query is running multiple times over and over again, it does help performance. However, with the JSS, we're very frequently running completely new, unique SQL queries. We've found that just disabling this, as well as the query cache size, means that SQL won't even try and cache those queries or retrieve them. And we've had much better performance with that, especially as we leverage memcached further and further. Oh, table open cache. Table open cache is the number of tables that SQL can have open simultaneously for easier retrievals. There's a couple SQL queries. We have them listed here. Your support rep can get them to you anytime if you're curious about examining them yourself. Things we look for are the number of tables increasing rapidly at a very quick pace. Then we know that we need to increase this a little bit higher. We can also look at how many tables are currently open and then compare them to what the maximum value is, kind of increase them a little bit further as necessary. Generally, not always, but what we've kind of been working with is updating them in segments of 2,000. So if we do see that the current default is set to 2,000, we then move it up to 4,000. If we don't see that that's enough, we can move it up to 6,000 and so on and so on. It is a value that will increase RAM the more and more you increase it. So that's going to be one of those where we kind of need to find the proper value based on available resources, but what we need to have. Unfortunately, there are some operating systems that do have a hard limit to what this value can be. The U limit of the operating system itself prevents us from increasing them to any specific degree. Examples of this are Mac OS and CentOS. Both of them have hard-coded limits to what we can modify with the table open cache. Finally, I'm going to be discussing the key buffer size here. Key buffer size is, for lack of a better term, the amount of RAM each SQL query could possibly use to complete. SQL's rule of thumb is generally about 25% of the server RAM. However, this value does max out at about 4 gigabytes. After 4 gigabytes, you're literally not getting anything else out of it. So, very useful if you start to see some of the queries running a little bit long. There's a couple different formulas floating around the internet about what to look for in regards to key buffer size and whether or not it needs to be increased. I myself haven't found one that I particularly like, so I'll juggle back and forth between about 3 different ones, see if this value needs to be increased. If we have the available server RAM, it is certainly something that you can go ahead and increase as necessary. So, we do got some time for a couple of questions, if anybody has anything they'd like to run by us. I do also want to draw your attention to the panel we have tomorrow. It's a full Q&A panel in regards to, what was the name of the panel? Scalability. Yeah, that one's around 11:30. And there's also a scaling in education in the afternoon, as well as scaling for commercial on Thursday. All of them are going to be really great information. But if there's questions for us immediately, we can absolutely tackle them. So, or you guys just look at me. I'm fine with that. Yes?
So for setting up things like Tomcat monitoring, do you guys have documentation available on recommended approaches?
I'm not familiar with any knowledge base articles that we have about it. Oracle has really good documentation on the specific Java arguments that need to be configured in those files. And as always, call into support and we'll help you through it.
Okay. The reason why I was asking about that is that this issue of monitoring has come up in several occasions with me, and I always ask, okay, so how do you set up the monitoring? And then I don't really get good answers back after that point. So it'd be very helpful specifically for Jamf Pro to know how to set up particular monitoring so that when support says, do you have monitoring set up? I can say, yes, I do. And here's the one that I set up in accordance with your documentation.
Sure. Yeah, and I'm sure each different monitoring software probably has a little bit, intricacies with itself. But what you need to enable on the Java side of things is all pretty standard. So
Have you tried to look around on Oracle's website recently?
I was on it earlier today. Yeah.
I mean, this is something that I would really appreciate if Jamf would take the lead on for your specific solution, helping your customers to configure the monitoring for, say, at least JMX monitoring correctly.
Sure. Yeah. Thank you.
Mike was just saying that
Yes.
that information was added to the new CJ, which is the Jamf 350 course going forward.
And that is public documentation.
Yeah, so support, yeah, we'll work on that. But yes, it was just recently documented and put out for the rest of the jam, so. You guys repeat that
Yeah, it was just documented by the education team at Jamf, so that is new information that is being documented and currently being distributed. So we're on it.
Regards to max connections, scaling, whatnot, what do you recommend setting max connections, increasing max connections on a MySQL server in like an auto-scaled environment, where the number of web apps is kind of dynamically changing at any given time?
Crank it high. I have a number of my environments sitting at 1,500, which is a ridiculously high number. If we start getting to the point where we need 1,500 connections, we need to look at some other things. I had been working on a number of scaling settings where we had gone back in and been adjusting the max connections each time that we needed to make a change to max pool size. Eventually, both the client and I just got sick of it, so we just cranked it up to 1,500. It's still sitting there, and it's not negatively impacting them at all.
Are there any other negative implications to having it?
No,
high?
and bear with me here. You know, I've never been formally trained on SQL. All I have is my real-world experience. I have not seen any performance issues or negative hits by having max connections, and max connections specifically, scaled higher than it needs to be.
Thank you.
Hi. So we had some issues recently with scaling and a great deal of performance issues, and we had tried every possible scaling permutation that we could, and eventually it came down to reducing both max pool size and max connections, and that still didn't do it. The only thing that actually helped us was moving the database engine to InnoDB. What I'm curious about, though, is that there seemed to be what I'm curious about, though, is it seems like there was a bit of a feeling of resistance to doing that. I had discussed with quite a few of my colleagues some of the issues we were having right off the bat. They said, what database engine you're running? And they said, move to InnoDB. And when I brought that up to Jamf, we kind of had to go through a few weeks of attempting changes in scaling, which did not help us at all. The only thing that helped us was moving to InnoDB. So I'm just kind of curious why it is there seemed to have been some resistance to moving us towards that. And mind you, we're not a huge environment per se. We have 6,500 iPads, 1,000 MacBooks, but it was still well past the point that from people I had talked to that we should have already been moved over to there. So.
Anybody? You guys want me to do it? Okay. All right. So I probably have more experience with InnoDB than anybody. Maybe not Garrett. Maybe not Garrett. As far as the support staff goes, I have quite a bit of experience with InnoDB. The reason you're going to get resistance from support for the immediate future is my.isom, it's kind of our bread and butter. My.isom is fairly straightforward in the variables and the way that it communicates, and it's also the way we've been doing things forever. Generally, it works for 90% of our environments. You're right, as we are doing more and more with the JSS, we're finding that my.isom can't keep up the way that it used to. It's still the default engine because it does work with so many of our environments. When you start to work with the InnoDB database storage engine, it introduces a whole host of variables. Off the top of my head, I can double that list just for InnoDB. It's not that they're bad, it's that it's not something we've been hands-on with. We do all of our testing against my.isom. All of the InnoDB conversion, the InnoDB stuff we've been doing has really been, okay, let's try this. Performance seems better, fantastic, we're just gonna go forward with it. But because of that element of unknown, because of the element of it's not the way we've been doing things forever, it is something that most people, myself included, are still very hesitant to go forward with, unless we do see the absolute need of, nope, we know for a fact this is going to fix it, this is the only option left to us, this is the route we're going to go forward with.
No, makes sense. Thank you.
Oh, something.
A little bit more on that too is there can be some underlying issues that just converting to InnoDB can mask, and we really want to thoroughly check through all the potential issues and address them before just going to InnoDB, and then even after that conversion there might be an issue underlying that the conversion is just masking because it's a little bit more efficient.
Well said, Garrett. Yes, thank you.
All right, in our environment, we'd like to host multiple Tomcat contexts so we can have different servers for different customers. And it's not been possible to load balance multi-context Tomcat in the past. Will that be available in the future? Is that something that will change in 10?
Strong feelings, either of you gentlemen?
Seeing it was not possible to load balance a multi-context deployment well.
Yeah, well, it just doesn't work. The documentation says it's not supported. And in our experience, it just stops working when we try to load balance multi-context environment.
I'll have to get back to you on that.
Okay.
If you do want, please feel free to spin up a case about any of this information. If you guys have any questions on specifics, please feel free to spin up a case with your support tech. If nothing else, they can touch base with one of us, somebody else who's an expert, especially on something we can provide further research in, such as that topic.
Hey, I'm going to pull a Rich and pretend to ask a question when it's really a feature request. So some of us that are in cloud, in our own clouds, not your cloud, we're auto-scaling groups, and in my environment, we have a rehydration requirement where we have to nuke and pave every 60 days. So with that, we have to fully automate our JSS installs. So all of the custom configurations that we have to do, we have to script, we have to do the install, stop Tomcat, script and set and awk the heck out of everything to put your settings in place and restart it back up. And we have it working, but it'd be really nice to have the option to run the installer with options or with a configuration file where you just run the installer and have an argument for your configuration file, and it does all your custom variables in set m.sh and Tomcat properties and everything else. So have you thought about that, or am I just too unique for that to even be an option? The other thing too is with the JSS installer, it's interactive, so you have to put it inside an expect loop, and that's kind of a pain too. But you can get it to work. Oh, yeah.
Well, I actually found an even simpler way to do it. Since there's only one question in the JSS installer, and it's yes or no, I do yes, pipe, then JSS installer, done running.
Nice, cool. Very cool.
Certainly a feature request, no, I don't think any of us on stage here have ever considered something along those lines. I don't know if it's an option for your environment, the manual Tomcat installer, if that's something you could script a little bit easier. Shaking your head, no. Okay, I understand. Most likely, yes, it's going to be a feature request to have that additional functionality built into the installer.
All right, and one last question. Awesome.
So our data center team runs everything off of VMware, and we use Windows Server for pretty much everything, which means for our monitoring that they use, they pretty much exclusively use SCOM. And have you guys used or seen SCOM, and if that's possible, or would it be more beneficial to get more insights with JConsole and Zabbix?
I haven't personally been exposed to that.
Thanks.
Yeah, I have not personally been exposed to that software. Anybody? No?
Okay.
So, I mean, as long as there's no conflict there, leveraging multiple monitoring software, you're only going to have more to work with. Generally, a lot of these softwares are working with, scales, graphs, things that, anybody be able to take a look at and give you a little rough estimate on. If it is possible to leverage multiple monitoring software, going forward, we are starting to get the team, support as a whole, more familiar with leveraging monitoring software to some degree. So using something that's not universal, that support's more familiar with, is going to be able, it's going to help support help you.
Okay. Thanks.
All right, and with that, that's the end of Tomcat and MySQL tuning. Thank you all for coming. The next session starts at 2:45. Thanks, guys.